Hello, this is Saxon Algebra 2, Lesson 113, and it is about logarithms and antilogs. And we're going to start, because they are so related, we're going to start with our laws of exponents, which you already have in your notes. So the first law of exponents says if my bases are the same and I'm multiplying, I can add my exponents, such as x to the second power times x to the third power is x to the fifth power. The second exponent law is if I am dividing with the same base, I subtract my exponents. And the third is if I raise a power to a power, then I multiply my exponents. We call m and n, in both of these cases, exponents. We could also call them logarithms, because a logarithm is an exponent. Logarithm and exponent, they're the same thing. So let's start with two specific bases. We can do this with any base, but two specific bases is base 10. That's log base 10. And that is on your calculator, the LOG button. It's understood to be base 10. And then log base E, that special number E, on your calculator, it looks like LN. So let's see how this, these are related here. So if I have 10 to the third power times 10 to the second power, we've already talked about that's 10 to the fifth power. I can also write log base 10 of log base 10 is understood of 100,000, 1, 2, 3, 4, 5 is 5. That's because 100,000 is 10 to the fifth power. The logarithm says I know the base is 10, and I know the antilog is 100,000. So I'm looking for the exponent, or what we refer to as the log. This one we know because we know our powers of 10. We could do the log of 3, and that's asking for the exponent that we raise 10 to get 3. So on your calculator, this is where this is going to come in. You're going to punch the LOG button, which is understood base 10, and the 3, and it's going to give you the exponent that you raise 10 to get 3. So I'll let you do that. The other base is base E. So we could do the same thing here. So the natural log of 3 is some number. So you're going to looking for the number that you raise E by to get 3. So on your calculator, you're going to punch the natural log button and the 3. It's going to give you an answer, and that is the number that you raise E by to get 3. One of your D practice problem is log of x equals negative 4.16. Log of x is equal to negative 4.16. And this says, because he's understood to be base 10 right there, so this says 10 to the negative 4.16 is equal to some number. And that's the antilog here is what you're looking for. The antilog is what you're looking for. So your calculator, you're going to put in 10, you're going to raise it to the negative 4.16 power, and that's your value for x. Same thing with C. You've got the natural log of x is negative 4.16. What you're looking for is the antilog. The antilog is the number that you get when you raise a base to a power. So in this particular case, your base is e. You know that because it says natural log. You take e on your calculator and you raise it to the negative 4.16 power, and you're going to get a value, and that's the value of x. Now, one case where this comes in handy is when we are dividing very small and very large numbers. So let me get this practice E on the board. We've got 0.000612. We're multiplying it by 576. We're dividing it by 0.0512 times 10 to the negative 14. Your instructions say to use your natural log on your calculator to figure out what this is. So to figure out this value right here. So what we're going to do is we're going to write each of these as a power of e. And then we can just add and subtract our exponents. So with our calculator, we're going to take the natural log of 0.000612 and hit natural log, and I get negative 7.399. I'm going to put it. Check that on your calculator. I'm going to take 576 and hit the natural log button. Some of you will put the number in and hit the natural log button. Some of you will hit the natural log button and put the number in. Depends on your calculator. But I get 6.356. I'm going to take on the bottom. Again, I'm just rewriting each value as a power of e. And I get negative 2.972. And then the last one, I got 10 raised to the negative 14. Where's my raised to? There it is, right there. Alright, let's do that. Nope. Negative 14. And I got 10 raised to that power. Negative 14. I got to do a second on mine. Yep, that. And then I take the natural log of it. I get negative 32.236. Now that I've gotten all four values written in the form of a power of e, I can apply my first two exponent rules and add and subtract. So on the top we've got e to the, I'm going to do this on my calculator so I don't have arithmetic error. I got e to the negative 1.043 divided by, on the bottom, 2972 and 32,236. So I got e to the negative 35.208. My second rule, remember, says to subtract those. So I'm going to take 35.208 and I'm going to subtract from it 1.043. So I'm going to end up with e to the 34.165 power. If I go ahead and, I should have left it, 0.165 second e to that power, it gives me 6.88 times 10 to the 14th power. So one of the advantages to doing logarithms is the handling of very large and very small numbers. And so, all right, that's the end of that one. Thank you very much.